All right. So we go to the point where we said that we derived all this equation, and then we saw the performance index, the Z, right? And then we go to a point where we write this equation from the performance index equation. And then we said that we are going to use what's it, a slope of 1. And then we said we are going to use this one here for the ranking. We're going to use the slope of 1 for the screening. So let's see what we get. So in the end, we will get a graph similar to this one. Similar to this one. So let's see. Now we move to the software. So you see, now we've opened the software. So database is already selected, right? What we do here is that because this material here is, we don't know the one that will best. So we get here, that irrespective of the database chosen, you go here and select, you go to materials universe, and you go to all materials, meaning that it won't only consider polymers, consider everything. So you see, we have even metal polymer. And then we go to the next one. What we do is that, what do we get? We have this and then this. So what are we going to do first? We have all these materials. So 422, as we can see here, 422, all these materials are selected. So the first thing that we are going to do will be to, let's say, screen. So let's see. To do a screen, we're basically going to use a chart. So because if you are going to use the screen, as we said, I mean that we're going to use the slope of 1, which you said is what is equal to the slope of 1. First of all, do the screening. So if you are doing the screening, we are using the chart, because if we are saying the slope is 1, you have to use the chart to do the screen. So we come here, and then we go to the chart, and the chart will just show us all the materials that we have. But then let's see. You see the equation that we did here, the performance features that we end up getting thickness at the top and then density at the denominator. So I mean that, as we said, we're going to put y to be as thickness. So when it comes to software here, we have the y-axis. We're just going to make that as thickness. What type of properties that we know that to be, and we come down and we go to what stiffness, or what here we have, so that one is set. And then look at, you see all the equation that we did here, everything was in log. So the scale that we have here is in log. And then we go to the x-axis. The x-axis, what we are using for that one, density. We know density, come to category. We know density is always a physical property. Physical, we go to attribute. And then the software I'm using here is the student leadership sponsor. At the moment, we are supported by university, right? And density, right? But now that we have this, it's still logarithmic as so we still maintain it here. Now that we have all this, we go to OK, and it gives us the chart. Let's see what. Okay. So now that we have this chart, this is what we get from it. As we see, all the materials are showing. All the materials are showing. What we just done here, we just doing this equation to show us the graph, so we can screen some of them. And so we use this to do the graph. Now we're going to screen some. This point, yeah, this is fine. With the screening, what happens is that we're going to use a slope. So we basically use this equation here, which is the same as this one, to get this one right. We have all the candidate material showing. I think at this point, we can take, we can close this one. But just so we can follow what we are. That's all. Okay. Just so we can follow what we are doing. We are just so now we have this graph, right? And then you see initially we had 42 materials past all that we are doing. Right? Yeah, we have 42 materials past, and now we are just left with 417. Right? Some of the materials have been cut off because we use this equation, and then we're going to use the slope to make sure we get maximum. So you see we have young modulus E here, on this side, right? Here we have E. Here we have density as we see in this equation, right? This is our Y. E is our Y. Density is our X, right? Okay, the Y is equal to MX equation. So what it says is that clearly looking at this graph, we can see that the ones that will be the best will be the ones showing on this side because density is increasing. Now listen, we basically combine these two. We combine these two. The one that will appear here, the one that will we combine this, right? For modulus and combine, right? So the one that will appear best will be the ones that appear at this side of the equation, right? The ones that will appear here. So here is the point where we do the screening, right? Here's where we do the screening. Let's see, let's compare. The stiffness E is here, the density is. So the ones that will give us the best of this will have to appear somewhere. So that's why we will use the slope to select this one. So let's see. So clearly we know we want the density to be small, we want the stiffness to be high, right? Highly we are prioritizing the what's the name? The stiffness, right? So let's see. So we use this one here. So you see what's the name of this one? It's particular line called slope or something. So index and display line. So display line is what we give us the slope. Go to this, slope is already here. 1. So maximize the index. And the index is what we selected to be the young modulus. The index is what we selected to be the Young's modulus and the density. Combining this. So we are maximizing. Right? So when we do this, we select this one. Maximize is selected. Then we go to OK. And then let's say we draw this line. Right? So now that we draw this line here, this is what we get. So yeah, initially you started with about 4224 material, right? And then we end up with after the graph we have 4172 or so. And now after we've done this, that was it. We've done this screening with this slope here. You see we have 396 material. And then again, you can move this line to just reduce, do more screening as much. You see 140 now. The more you move it, you have 52. So the more you change, you move this line, right? The more or less material. Let's see. Let's keep it this with this one. Right? So now that we have this, in fact we are done with it. You see, the materials that are grayed out, the ones that don't meet the ones that their modulus also that index is low, right? And the ones that appear the ones that are potential. Another thing to it that when it comes to this material, let's zoom. Okay, let's zoom. When it comes to the ones that collect, when it comes to the ones that are colored, okay. When it comes to the ones that are colored, the ones that appear just above the slope line that we've done are the ones that fully meet the requirement, right? And the ones that appear below it, not all the materials within it meet the full. So when you zoom in here, you see that. So all these are kind of like classes of material, all the kind of red ones here. Some of them touch the line, some are above the line. The ones that are above the line, they completely meet the condition of the within. And this chart here is what we call a globe. You can use any other, but here we are using, yeah, it's called global chart or something. What are the shape of this? So the shape of it. So now that we have this, see that the materials that kind of like the screen that we're having now is this one. So you see now we've done the translation. That's why we're writing a lot. We've done the screening using the slope of this line. Slope of now we're going to do the ranking. But when you come to this side here, see you've written the stage there. The three here, see there's ranking here. You come to this side where we see vertical. Right? Drop down the menu. and you come to this one. So you see, we have was it the name is index value. So we are going to rank it by the index value, and the ones that have the highest index value. So this was when we started. We said that we instead of using density on stiffness, we changed it to stiffness to density. Stiffness on density. So if we do it this way, we choose this one to rank it based on the ones with the highest value. It's the ones with the highest value. So you see this materials here. So it means that all these materials here have been ranked based on the ones with the highest value that we have. Even if we try to move this line up, right? And then again, we are aware that this line here is used for screening and to remove some of the material. You see now we have less material. The more you move it up, the more you screen, less material. So yes. Okay. If someone is selecting a material for the stiffness light, the light, high stiffness, and then light for tension, these are the ones that will the so you see boron carbide, so boron carbide, another one is quite hot isostatic present. This is hot. All these ones with looking at this, so let's you see we ranked it based on it. So the one with the highest value here, which is this, is the 0.36. The index that I have on this one is the highest index, which is yeah. So this one has the highest index, the one that we did of 0.36. This one has 3.184. It ranked it the one with the highest fit. So, yeah. Once we maximize it, we rank it, it shows that it makes our work easier. This one is the one that works best for what we are doing based on the characters that we give it. Right? So that's all that we did. We did the translation, we did the screening using this loop here, and then we did the ranking using the index. We said we ranked it based not on density alone, not on based on and the one with the highest index. That's this one, right? Which is this performance, which is the carbon fiber, right? And then let's see more detail. That is ultra high modulus, right? And then see below as well. Fibers, carbon fibers. I want to perform best for this case. So that's it. That's it. So each and every case based on, and then we said one thing that we skipped so far is the free variable. So let's say someone has gone through the whole selection process, right? But then these are the materials that they have. You can choose to move down this one to get more, right? To get more material based on. So you check this. Oh, I don't have this material. I can't afford it. I go to the next one. I don't have this. So you keep on going down. You see the one that meets you, that fits what you have the best. Whether you can afford it or it's available to you. Yeah. So that's the free variable. How that we are saying that the selection of the final material depends is a free variable that depends on the whole person who's in it. Right? And then the scenario and then who we are doing the whole material selection. So this one based on just the performance index, the one that performs best will be the carbon. Right. So that's it.